Quantum computing focuses on developing technology that takes advantage of the way energy and matter behave at the subatomic level. Even though there's been a lot of hype, it hasn't been easy to commercialize. Atomionics is a deep tech startup which specializes in quantum sensing technology, which has endless commercialization opportunities. One of the products they've developed enables mineral exploration at a fraction of the cost and time of traditional sensing technologies. Sahil, with Atomionics, you've developed new quantum sensing technology. How can we think about that in terms of the comparison with traditional electronic sensors?
There are two things that matter in sensing. How small your scale of measurement is and how well can you maintain that scale. For conventional electronic systems or laser-based systems, the scale that they use is the wavelength of light or sometimes electronics as well.
Okay.
This is essentially like having a normal ruler. Whereas with quantum sensing, we essentially use a thing called as cold atoms. Now here, these cold atoms have their wavelength to be 10 raised to 10 times more sensitive than light-based or electronic-based systems.
So for example, the mineral exploration companies that are some of your customers, how has their workflow changed from where they were to now using your technology?
There's a lack of high-resolution data in the mineral exploration industry. What that means is that right now you actually have to send a technician or a geologist to the field to take one measurement over 10 minutes with an instrument called a gravimeter or a gravity measuring instrument. Now this process is repeated over thousands of kilometers and it takes years to acquire this data as well. Even after you do this, if you imagine collecting a map or building a map through this, your pixel size on the map is going to be the size of a football field.
Okay.
And
not very useful.
Not very useful. So you do just hundreds of drills to identify where these minerals are through trial and error. And they end up spending $21 billion on doing this. This is where we realized we had an ideal solution for this. We just deployed our solutions on the back of a pickup truck and just drive around to acquire data. Using this, we can provide 10,000 times higher spatial resolution, and within a matter of weeks instead of months or years that it would conventionally take. So you can essentially avoid all the false positives or drills that didn't end up into mines by using this high precision gravity maps. And so it actually reduces their cost of drilling by nearly an order of magnitude.
When you think about other applications, marine navigation is something that was really interesting that you have created developed a solution for. How does the marine navigation system work?
A submarine that is traveling from point A to point B with conventional navigation systems, it ends up nearly 1 kilometer astray from its actual location. Inertial navigation systems have this inherent error called drift, and they have to come up to actually access the GPS signal because GPS doesn't penetrate underwater and essentially is giving up on its stealthiness, right, which is the key selling point to actually have this $5 billion submarine. With quantum sensing, you can actually navigate from point A to point B and have nearly 1,000 times better accuracy in knowing the location without actually having to surface for this GPS calibration.
What are some of the other use cases for the quantum sensing technology you developed?
Another thing that really excites us is the fact that we can create a completely new global positioning system. We measure gravity so precisely and in such a way that we can create a unique fingerprint of any place. And using this fingerprint, we can position ourselves anywhere in the world, be it underwater, underground, or even in space.
In space. So when we think about space exploration, which is a really exciting future, and mineral exploration, for example, on the moon or on Mars, how do you see that unfolding?
I'm a massive space buff. And so it almost feels like we are back in the 1700s trying to explore new lands.
Right.
And back then...
Well, it is very much like that.
Exactly.
The new frontier.
This space is the next frontier. We don't really have Google Maps to take us from the Earth to Moon or Mars. We envision that gravity-based universal positioning systems can actually satisfy that need to help us navigate in the most efficient fashion and actually identify these things called as gravitational superhighways,
Okay.
which are the fastest points between two different planetary bodies.
That are moving in three-dimensional space.
Exactly, because your planets are also revolving around the sun. So these superhighways are almost moving all the time as well.